Sorting is nothing but what? That is an arrangement of element in some order, whether it can be either ascending order or a descending order. An ordered collection of elements, I can insert and I can delete the elements from the only one end. I can call that as a top of a stack. So this pop operation is nothing but deleting one element or an item from the stack. Hello everybody, welcome to the 6th session on 4th chapter, that is data structure. I am Rohini, lecturer, Department of Computer Science, Vidhyaashram Pre-University College, Mysuru. So in our previous session, we learned about sorting the elements. So as we all know that sorting is nothing but what? That is an arrangement of element in some order, whether it can be either ascending order or a descending order. In that we learned about the definition and also I have discussed the algorithm with examples. So that is also very important. There we had learned about insertion sort. That is very important question along with the algorithm and example, that is regarding sorting. And also we had a discussion regarding what is two-dimensional array, how we are going to represent that two-dimensional array. It can be either row wise or a column major method. So that is row major method or a column major method. That is regarding the representation of a two-dimensional array. And also I have discussed what are the applications of an array, where we are going to use the arrays and what are the advantages we have. Along with that I have discussed about disadvantages of an array. So in today's session we are going to start a new topic, that is stacks. So we know the difference, that is the classification of a data structure, primitive and non-primitive. When it comes to the non-primitive data structure, again it will be divided into what? Arrays, list and files. So when it comes to the list, there again it will be classified into linear and non-linear. So in linear we discussed about arrays, that is over. Now we have a stacks. So now in today's session we are going to learn about what is stacks and how we are going to represent the stacks in the computer's memory, and also we are going to learn about what are the operations that I can perform on the stack and what are the algorithm we have. Based on that operation we are going to perform two operations, that is push and pop. For that we are going to have the algorithm and also I am going to discuss about the applications of stack. So where we are going to implement this concept. Everything in today's session I am going to discuss. So now let me get into the today's session, that is stacks. So stacks comes under linear data structure. If it is a linear data structure, then how the arrangements of elements should be? It has to be in the sequential order. So that means what? One element to be allocated or one element to be seated where? In the sequential fashion. So that is one element after another element. That is nothing but what? Linear data structure. So stack is also one of the linear data structure. So a stack is nothing but, the definition of a stack is very important. What is stack or define stack? So if you look into this image, how we are going to get to know? So this is nothing but what? Stacks of books, and this is a stacks of coin. That is a collection of elements, that is an ordered collection of elements in which an element may be inserted or deleted only at the same end. Very important point. So then how can I define stack? That is an ordered collection of elements. I can insert and I can delete the elements from the only one end. I can call that as a top of a stack. So if you look into the example, here I have a stack of book and stack of coin. So how can I define this as a stack? Because this is an ordered collection of elements. If I want to pick this book, how I am supposed to do? I have to remove this book first. Then I have to take this book out. Then this one. After this one. Then I am going to get a book or a element which I require. So insertion and deletion will going to happen only at the same end. I can call that end as a top of the stack. I can call that end as a top of the stack. So if I want to add new coin or if I want to add new book to the particular stack, then how I am supposed to add? I am going to add a new book on the top. What it mean? Insertion and deletion of an element will going to take place at the same end. That end is nothing but top of a stack. So this end is called as the top of a stack. So we are going to call this as what? Top of a stack. So what we have reverse of that top, what we call for the least element, or what we call for the first book here, that is base. That is base. That end is called as what? Base. The end opposite of a top is known as what? Base. And which methodology this stack will going to perform, or which methodology this stack will going to follow? That is LIFO. So LIFO in the sense what? Last in, first out. Last in, first out. So if you look into the image of this stack, that is stack of coins, which coin will going to be executed, or which coin will going to be deleted first, that is which is at the top. So it came last and it will going to be deleted first. That is last in, first out. Those who come last, they are going to leave first. That is what the scenario that you have to understand when it comes to the stacks. So now you got to know the definition, and your insertion of an element and deletion of an element will going to take place at the same end. That end is nothing but top. So exact reverse of the top is base. The first element that we are going to insert will going to be in the base. The newer element or newer data that you are going to insert to the stack will be in the top. So that is what you have to understand when it comes to the basic things about the stack. So now let me take one more example to make you understand this stack. So in the real time scenario I am going to take. So if you have seen any of the cafeteria, there will be a what? Stack of trays, right? So there will be a stack of trays. So which tray you are going to take first? So which is at the top. So that means what? That it will going to follow LIFO format. Last in, first out. The element or a data which is at the top, that will be removed first. That will be going to be removed first. So that is the scenario that you can consider. We have stacks of books, stacks of coin, and stacks of plates, stacks of any trace. So that is what you have to understand with a real-time examples. So now we'll see how we are going to represent stacks in the computer memory. So when I'm creating a stack, at the time computer memory will going to allocate some memory space for the stack, right? So we'll see how we are going to represent a stack in a computer memory. So there we have two methods. So we have two methods in order to represent the stack in the computer memory. If it is a static memory, representation, then we are going to use a concept called array. If you want to represent the stack in the dynamic memory, at the time we are going to use a concept called linked list. But here we are going to learn about the static memory representation, that is array. So we are going to use an array concept in order to make or in order to represent the stack in the computer memory. So before that you have to understand some of the terminologies in order to represent a stack in the computer's memory. So we'll see now. So stack can be represented using one-dimensional array. As I discussed, when you want to represent the elements of a stack, or when you want to represent a stack in the computer memory in a static manner, the data will not get changed and we are not supposed to add or we are not supposed to delete an element at its time of execution. That is static. So when we are working with static representation of an elements of a stack, then we are going with array concept. But when you want to represent the stack concept in a dynamic manner, then we are supposed to go with linked list. So if it is static, which is we are going to use, that is an array. So even in array, we are going to use one-dimensional array. So as we all know that one-dimensional array is nothing but that is a collection of element of the same data type. So that methodology we are going to use when in order to represent the stack. Okay, so when it comes to the one-dimensional array, how the elements will going to be stored? That will be stored in the linear order. one element after another element. It will going to have a continuous memory allocation. And one dimensional array can be either what? We can represent row wise, or it can be represented as a column wise method. So that is vectors. So that can be used in order to represent the stack in the computer's memory. So the items into the stacks are stored in a sequential order from the first location to the memory block. For example, here I have created one stack. How many elements are there? So it can be element 1, element 2, and element 3, element 4, element 5, and element 6. How I am going to add the element to the stack? That is from the top end. That is from top end. Then from where I am going to delete the data element? Even that is also from the top element. So inserting a new element is called push, and deleting a existing element from the stack is called as pop. This push operation and pop operation will going to take place at the same end. So that end is nothing but what? Top of a stack. That end is nothing but top of a stack. That you are supposed to understand. So the pointer top contains the location of the top element of the stack. So what this top will going to indicate? This will going to point to the last element of the stack. For example, if I have only 5 elements, then where the top will going to indicate? It will be in this location. So this indicates that this top pointer will going to indicates the last element of a stack. That will going to indicates the location or address of the last element or a top element of the stack. And we are going to use a variable called max STK, that is maximum stack. So that will going to contains the maximum number of element that can be stored in the stack. For example, max STK. So this is what this variable indicates, the maximum number of elements of a stack. So for example, max stack 5. So what it indicates? So this indicates that our stack can contain at most 5 elements. That represents the number of elements of a stack. For example, in some of the colleges, what they are going to do? So they are going to set the maximum number of students. So once they have reached that number, they are not going to allow for the new admissions, right? So that is nothing but what? Some scenario, some standards they are supposed to follow. So when we are going to use this max stack, that indicates the utmost value or utmost data elements of a particular stack. So for example, max stack 5 in the sense, we can add or we can have only 5 elements to that particular stack. That is what you have to understand. We know what is top and what is max of stack. That is what is the maximum number of elements for a particular stack. So now we are going to represent the stack by making use of the array. For that, we must understand what is top and what is maximum stack. So now we'll see, if we attempt to add new element beyond the maximum size, let me write a stack for you. So this, how I am going to represent the stack? I can use linked list and arrays in order to represent the stack. So let me take an array in order to represent stack now. So this will be one-dimensional array. If it is one-dimensional array, it can be row-wise or a column-wise. So that I am going to take 3 elements. I am going to take, let me take 4 elements. So 10, 20, 30, 40. So this is my stack. Okay. So this is my stack and it has how many elements? It has 4 elements. So what top will going to indicate? So top will going to indicate the last element of a stack, or the new element of a stack, that indicates top. So what is the top value here? That is 40. And if it is array, how the index starts from? That is 0. A of 0, A of 1, A of 2, and it represents A of 3. How we are going to find the length of an array? That is upper bound minus lower bound plus 1. So if it is 3 minus 0 plus 1. So 3 minus 0 will be 3, 3 plus 1 will be 4. That means what? What is the length of this array or stack? That is 4. If it is 4, then it will going to have a of 3 as a address, and we can store 4 data elements. So this top indicates the location of the top element of a stack, and insertion and deletion both will going to happen at the same end. That we are going to call that as a top. Okay, but when we are going to insert a new element beyond the maximum size of a stack, then we are going to end up with a scenario called stack overflow. That is stack overflow. So what does this stack overflow indicates? Stack is already full, but you are trying to insert a new element into the stack. Then that is nothing but stack overflow. So here the maximum stack is 4. But I am trying to add a new element to this maximum stack. At that time, we will end up with a scenario called stack overflow. Already stack is over, that is already stack is filled or full. So, but I am trying to add a new element. Is that possible? No. If it is want to be possible, then I have to increment the top value. I have to increment the top value that I am going to discuss in the push operation. Okay, so as of now, you just understand what is stack overflow and what is stack underflow. So when it comes to the stack overflow, already stack is full, but I am trying to add a new element, new data element, that is stack overflow. So now we'll see one more scenario. I have created a stack, but I don't have any element in the stack. So my top pointer will be in the base itself. I don't have any element in the stack. I want to delete. I'm trying to delete element from the stack, but I don't have any element. So that scenario is nothing but stack underflow. So that is stack underflow. You cannot remove an element beyond the base of the stack. So here top and base both are at the same place. That means I am trying to access the first element, but I don't have any element. If I am trying to access the element which is beyond the base, then there will be no element. At that time, what we will going to notify, that is stack underflow. We are just trying the element to be deleted, but there is no element. So that is also known as what? Stack underflow. So if you are trying to add new element to the overloaded stack, that is overflow. Okay, so the condition top is equal to maximum stack. Very, very important. These two are very, very important that you have to understand. Okay, so the condition top is equal to max stack. That means what? Top is here and the maximum size of a stack is also pointing to the same position. Top is also there and the maximum size is also there. If that is the case, that indicates what? Stack is full. I have only 4 elements to be added to the stack and it is already filled. When top is equal to max is equal to same, when top is equal to max stack is equal to same, then stack is full. But top is equal to null. So I have a top here. So top will going to indicate the location of a last element of an array. Right? Last element of a stack. Is top is equal to null. If top is pointing to the null element, that is no element. So that scenario is called as what? Stack is empty. That is scenario is called as stack is empty. Let me show you an example here. So these are the memory addresses. These are the memory addresses. It starts from 0. Why? Because we are using an array. So array's index starts from 0, 0, 1, 2, 3, 4. So maximum size of this stack is what? 5 elements. We can store 5 elements. And I have only 3 elements here. At most I can store 5 elements, but I can store the elements beyond the maximum stack. That is lower the maximum stack. 5 elements. I am going to give you 5 samosa. It's your wish. You can eat either all the 5 or only 4 or only 3. That is left to you. If you have eaten 3 elements, if you have eaten only 3 samosas, then the top will going to point to where? That is 3. But if you are left out with samosa, I can give the same samosa to any other students. That means what? I can insert extra 2 elements to the particular location. So here max stack is 4 and I have only 3 elements. So this indicates the null. So when the top is equal to null, is top is equal to null here? No. So that is stack is not empty and top is not equal to maximum stack here. So that top stack is not full also. I can include and I can remove the elements from this stack. And how we are going to represent this stack in one-dimensional array? As I told, it can be row-wise or a column-wise. I have shown the column-wise. So now let me show you the row-wise. So the maximum stack is 4 here. The maximum stack is 4 and I am going to take the 2 elements. I am going to take only 2 elements. 10 and 20 will be the 2 elements of this stack called S, and maximum stack is 4. At most I can store 4 elements. So this will be my top. That indicates the location of a last element of a stack. If I want to remove the element from the stack, which element will going to be removed first? That is 20. After that, I am going to delete this 10. Okay. So this indicates A of 0 and this indicates A of 1. So this is how the representation of a stack with the help of an array in the computer memory location. So now we'll see about the operations of a stacks. What are the operations that I can perform with a stack? So stack is nothing but what? Ordered collection of an element. I have to remove and I have to add new element at the same end. That end is nothing but top of a stack. So which is the first operation of a stack? That is stack itself. If I want to perform all the operation, I have to create a stack first, right? Then how we are going to create a stack? That is by making use of a stack operation. That is, it will going to create a new stack that is empty. I am going to create one stack that will be empty. With the help of this stack operation, I am going to create a stack which is empty. How can I leave this stack as an empty? I want to add new element to the stack. That is nothing but what? Push operation. So, push of item. What I am going to push? I am going to push an item to the stack. That is, it will going to add a new element to the top of a stack. So, which is the top here? That is this one. I am going to add an element from the top to the stack. So it will come and it will come here and it will going to reach the first position. That is 10. The element is 10. So push in the sense I am going to add a new data item to the top of a stack. Then pop. Now I am feeling sad. I don't want any element to be in the stack. Then what I am going to do? I am just going to remove that from the stack. From where I am supposed to remove? That is from the top itself. So, if I have only one element, then top will going to point here. So, that indicates the location of a topmost element. I have only one element, then the top must be to be located or to be point to the location of that element only. So, pop in the sense what? I am going to remove that from a top of a stack. So, pop. Pop in the sense what? That will come back again. Then how my stack look right now? It will be empty again. It will be empty again. Now I am going to add two elements called 10 and 20. How I am supposed to add? From the top itself. So it will be going to reach here. So for now my top will be pointing to the first location or a base location, that is 10, and I want to add a new element called 20. If I want to add a new element called 20, then it will come here. For that, top will going to be incremented by 1 and top will going to point to the first element of that stack. If I want to pop, then which element going to be come out first? That is 20. Why? Because we are going to follow LIFO, that is last in, first out. I have inserted or pushed the element 10 as the first element. I am taking the second element as 20. So 20 will be the last element for now. So if I want to delete or if I want to pop that element from the stack, I am going to delete the lastmost element, that is 20, that will comes out of the stack. So as of now, my stack contains only 10. Okay. So which is the next one? Peak. So we know peak. Peak in the sense what? Topmost, right? So peak in the sense it will going to return the top item from the stack but does not going to remove it. It's just going to gives us which is the topmost element. For this, if I apply this peak operation, what it will going to return? It will going to return 10. So that means what? It will going to return the top item, which is the top item of that particular stack. So just consider, I'm not going to delete this 20. So 10, 20 and I have some more place, right? I'm not going to delete. For as of now, my top is here and this is base address and address starts from A of 0 and A of 1. So the maximum stack is, here the maximum stack is 3, 4. Okay. I am going to use this peak operation. When I call this peak operation, what will be the result? That is 20. It will going to return the topmost element. Which is the topmost element here? 20. If I add 30, if I push, if I call a push operation, it will going to add a new element to the stack. So now it become 30 and top will going to be pointed here, not to this place. So if I call this peak operation now, then it will going to gives me the topmost element, that is 30. So this is how the operation will going to work. Next we have is empty. Is in the sense what? I'm just checking is stack is empty or not. So if it is empty, then it will going to gives me the true. If not, then it will going to gives me the false. So it will going to gives only Boolean values as a result. So it will going to returns Boolean values as a result. If it is true, then that will be 1. If it is false, then that will be 0. So as of now, I have 3 elements, that is 10, 20 and 30. And the maximum stack is 4. And I can store new element to the existing stack. But I am not going to store. If I use this peak, it will going to return me the topmost element, right? But now I am going to check is empty. Is empty. Consider my stack name is yes. My stack name is S. For array, what we are going to do? We are going to take A. For this one, I am going to take my stack name as yes. So if it is S, I need to change here too, right? So is empty of yes. I'm just checking. Is this stack is empty? Is this stack is empty? Is there any elements are in the stack or not? We have some elements in the stack. So stack is not empty. If it is not empty, then it will going to return me a Boolean value called false. If it is false, then it will be 0. So there will be only 2 possibilities, either 1 or 0. If it is 1, that is true. If it is 0, that is false. That is regarding is empty. Next we have a size. Next we have a size operation. That means it will going to return the number of items on the stack. What is the size of a stack? How many elements it has? So that is regarding size. So if I call a size operation here, what is the size of the stack? How many elements are there? I have 3 elements. So the size of a stack is 3. It has 3 elements. So this is about operations of a stack. I'm going to create a stack. I'm going to add an element to the stack, that is push. I'm going to delete an element from the stack, that is pop. I'm going to check the topmost element, that is peak. And I'm going to check whether the stack is empty or not, that is empty. And I'm going to check for the total number of elements of a stack, that is size. So this is all the operations that we can perform on the stack. So now let me move on to the push operation. Already we know what is push. So push and pops comes under stack. Okay. So push operation in the sense what? We are going to add a new element to the existing stack. That is nothing but push. So adding a new one element or item to the stack is represented by an operation called push operation. So then how I'm supposed to add the new element to the stack? That is from the topmost element, that is from the top. So that is the new element is added at the topmost position of a stack. So I have a stack here. Already I have 2 elements, but now I want to add a new element to the stack. So if I have 2 elements, then which is the top here? This one will be top. But now I want to add one more element to the existing stack. So that is push operation I want to perform. How I am going to perform? I have to check whether there is a place or not. Right? If there is no place, how can I add a new element? If there is no place, even if I am trying to add a new element, then that condition is known as what? Stack overflow. So that is stack overflow. I am going to check. I have 4. Maximum stack is 4 here. So I am left out with 2 places so that I can add more 2 elements or data to the existing stack. I am going to check if there is a possibility of adding a new element, then I am going to add it from the top. So I am going to add a new element called 30 to the existing stack called AS, and this become the top. So what it become? Top becomes top plus 1. So earlier the top value were in this one, S of 1. But now the top value is in S of 2. That is, top will be incremented by 1. So top will be incremented by 1. This is what we call push operation. Now let me get into the algorithm of this push operation. So push of stack. I have a stack. I am performing the push operation to that stack and I want a top element. So where we are going to insert an element? That is from the top. So I require top and I want to have a item. So where I am going to do? I am going to insert a new item into the stack. So that these are the possibilities that I require. So and I am performing push operation. Here stack is an array with n elements. I can take any elements. Okay. I can take any n elements and stack is an array. That is one dimensional array and top will going to point, that is a pointer to the top of the element of an array. That indicates which is the top of an array stack. And we have a item. Item is nothing but an element which is to be inserted to the stack or an array. So we'll see the first step. If top is equal to n minus 1. It is one dimensional array. So let me show you stack with one dimensional array itself. So 10, 20. A of 0, A of 1. I am going to create an array with a size of 3. Int A of 3. That means int is a data type, A is array name and 3 is the size of an array. So I have only 2 elements, that is 10 and 20. Now I am just trying. What I am doing? I am just trying to add a new element to the stack. But what I am supposed to do? I have to check whether the stack is full or is there any spaces there in the stack. So that is checking the condition whether the stack is full or not. So we'll see now. If top is equal to n minus 1. What is the n value here? N is 3. N is 3 here and I am checking whether the top is equal to n minus 1. Let me check. 10, 20 and top will going to be indicate here. Right? And n is 3, top is equal to n minus 1. So that is top is equal to 3 minus 1. If it is 3 minus 1, top is equal to 2. So that is A of 2. Is top is at the A of 2? Is top is pointing to this position? Is top is pointing to this position? No, right? If it is pointing this position, when it will going to point this position? When I have one more element. At that time, top become here. So now you just consider, I have 3 elements, that is 10, 20, 30. And top is pointing to the n minus 1, that is A of 2. If it is true, then what will going to happen? Print stack is full or overflow. There is no space, you can leave the stack. That is what? Print stack is full or overflow. If it is overflow, if there is no space, how you are going to add a new element? That is not possible. At the time you have to exit and you are going to end the if statement. Right? So this is the step 1. But what if it is not true? If my stack is not full, then what will going to happen? We'll see now. For example, I'm just creating a new stack called 10, 20. I have what I'm going to create int a of 3 and maximum stack is 3. And I have 2 elements. I have left out with one more space so that it will become a of 0 and a of 1. And the top element is this one. I have taken size of 3, but I have only 2 elements. So at most the maximum size is 3. I have only 2 elements. Now I am going to check. Is my top is equal to n minus 1? Is top indicating to a of 2? No, right? So that means was if condition become false. If this condition become false, then I am not going to print stack is full or overflow. I am just come out of this if statement. I will move to the step 2. That is what? Top is equal to top plus 1. So where is my top now? That is here. So top is equal to top plus 1. So top is in the a of 1, right? So where it is top? That is in the a of 1. Now I want to increment that 1 by 1. So a of 1 plus 1, that becomes what? A of 2. So where I am going to point the top now? That is a of 2. What is the top value? Where it will be now? That is in the a of 2. That is top is equal to top plus 1. So done. So step 3. Stack of top is equal to item. I just want to copy the item. Item in the sense what? The new element which I want to insert into the stack. That is the item. Now I want to add an item called 30 to the stack of top. So I have created a stack, and which is the top? That is a of 2. I want to add a new element called, what is the value of item? That is 30. Stack of top is equal to 30 in the sense what? I want to add a new element called 30 to the top of a stack. So here we have a top of a stack, and I am going to add a new element called 30. So what I did? I am just copying the item to the stack of a tab. So I am done with my work. That is, I have inserted, I have pushed a new element to the existing stack. So, and I am going to return. So this is about the push operation. We have only 4 steps. Okay, so just leave this written. We have only 3 steps in order to insert. I'm just going to check whether the stack is full or not. If not, I'm going to copy the item. I'm just going to increase the top by 1. Then I'm going to copy the item. So this is regarding push operation. So now we got to know how to insert a new element. Now just let me remove that element. That is regarding pop operation. So this pop operation is nothing but deleting one element or an item from the stack. Where we are going to delete from? Where we are going to delete an item from the stack? That is exactly from the top. That is exactly from the top. And we are going to call this operation as a pop operation. We are going to call this as a pop operation. When the deletion is not possible, when there is no element, then we cannot do the pop operation. Okay. So, ಸತ್ತಿರೋರ್ನ ಯಾವಾಗ ಸಾಯಿಸಕ್ಕಾಗಲ್ಲ or ಸತ್ತೋಗಿರುವಾಗ ಸಾಯಿಸಕ್ಕಾಗಲ್ಲ ಅಲ್ವಾ? So, in that way, when the stack is null, when there is no element, then we cannot delete any element. So, that condition is known as what? Stack underflow. We don't have any element, but just I am trying to delete that element. Already person is dead. I'm just trying to kill him again. Is it possible? No. That condition is what? Mission fail. In the same way here, if I'm trying to delete an element which is not in the stack, then that is stack underflow. Okay. So that operation is called pop operation. We'll see the algorithm here. Pop of stack, top and item. I want to perform a pop operation and I have a stack and I have to indicate the top. Why? Because deletion, either insertion, everything will going to take place only at the same place. That is top. So that top we require, and item is the item to be deleted from the stack. So stack is the array with n element and top will going to point to the top element of the array, and here item is the item to be deleted. So this is what and all that I have required. So now we'll see the first step. First, what I am supposed to do, I have to create one stack. So let me check. Int a of 2, a of 0, a of 1. Okay, I have created a stack of a name A and I have only size of 2. That means it can hold only 2 elements. Here I don't have any element. I have not inserted any element. So this will be my scenario. We'll check now. So if top is equal to null, which is the top here? This one, right? So this will be top. Is top is equal to null? Is top is equal to null? Is there any element in the top? No, right? That is null. If top is equal to null, then print stack is empty or underflow. So I have created an array or a stack of a size 2, but I haven't inserted any of the data element to that particular stack. But I'm just trying to delete an element from the stack. I'm just going to check whether the stack is empty or whether we have some elements in order to delete. Now my top is equal to null. I don't have any element to the stack top to delete. So that top is equal to null, so that stack become empty. So what it will going to print? Stack is empty or underflow. So when there is no element, what I can do? I cannot do anything. I'm just going to exit. I'm just going to end this if loop. Okay. So if this will going to execute it, then it will come here and it will just going to return. But now just let me take one more scenario. I have created a stack of size 2 and I have an element. So let me take 10 and 20. So these two are my elements. So now let me check the first condition. Is top is equal to null? If top is equal to null here? No, right? Why? Because top is equal to 20. Top is equal to 20, right? So that it will become false and it will come here. Item is equal to stack of top. What it is mean? Item is equal to stack of top. So what is there in the stack of top? I'm just going to copy that into the item. Already you have know that assignment how it should be. Whatever there in the right hand side should be copied to the left hand side. So that to the item, I am going to copy the stack of top. So now item become what? Stack of top. So what we have in stack of top? That is 20. So that item become 20 now. So this will going to be removed. That is top is equal to top minus 1. I'm just popping this one. So now what I'm doing? I'm just decrementing the top value by 1. So it was earlier in the A of 1. Now what I'm supposed to do? I need to minus this one. So 1 minus 1 become 0. Right? So top will be decremented by 1. Now it will going to points to this location. So when we are going to use the top, that is to indicate the topmost element. So if this top is indicating to this topmost element as a 10, then that means that we don't have 20. So it got popped. It got out of the stack. So this is nothing but what? Pop operation. I'm just going to return to the operation. Okay. So I'm just going to check. If there is true, then I will come out of that particular stack. If not, I am going to copy the content of a stack top to the item and I am going to decrement the top by 1. Then I will come out of that operation. So this is very, very important question for 3 marks or a 5 marks. You can expect this question mainly for the 3 marks. Most of the time they have asked for the 3 marks, either push operation or a pop operation. So these 2 lines are very, very important. You are supposed to write what are the variables that you are taking and what is top indicates, what is item indicates, everything you have to specify. Then write all the algorithm in a stepwise manner. So this is regarding push pop operation. So now we'll see the applications of a stack. Where we are going to use this stack, we'll see now. It is used to reverse a word. How we are going to use the stack in order to reverse a word? So let me take one example. I have a word called cap. Okay. Now I want to insert this value into the stack. How it will going to happen? C, then A, then P. So it will be like C, A, P. And how the pop operation will going to happen? So topmost element will come first and next topmost and next last base value. So initially it was cap, now it become PAC. That means what? Reverse of an word can be takes place with the help of this stack. That is, you can use the stack concept in order to reverse a word. You can push a given values or given word to the stack and you can just pop it out, then it just become reverse. Next, we are going to use a undo mechanism in the text editor. For example, already you are all familiar with a web browser. Okay, so when it comes to the web browser, there we have a tabs, right? Then we have a tabs. You are going to search for something. You are going to search for something and you didn't find, you are going to move to the next tab, right? So you are going to move to next tab, and if you have any hyperlink, then that will take you to any other tab. If I want to come back, how it will going to happen? There we have a reverse symbol, right? There we have a reverse button. I'm just going to click that. So if I click that button, it will come in the reverse order. It will going to be in the reverse order. So that we are going to perform an undo mechanism in the text editor. Or else I can also have what? Control Z. Whatever I have done previously, if I want to regain it back, I can use the Control Z. So at that time, it will just going to reverse. So if it is reversing, then the element or whatever the operation that has been done, that will be in the stack. So that purpose also we are going to use the stack. And backtracking, it is a process of checking or getting the most recently used data item. So when it comes to the web browser, if you check for the history, which will going to appear on the top of the history, that is most recently used. How it will be collected, how it will be stored? It will be stored as the stack. So for that purpose also we are going to use the stack, that is backtracking. Then language processing. So when it comes to the programming, there we are going to use a syntax. So pair of curly braces, whether we have used a proper way of curly braces, or if I have used only opening of a parenthesis and if I miss the closing of a parenthesis, then that will going to give us an error. So that error can be generated with the help of this stack. So the stack will going to find a match. So language processing in the sense what? It will going to check for the syntax. It will going to work with the syntax, whether we have the pair of curly braces, whether we have a pair of braces. So everything will going to be checked by the stack. And where we are going to use the stack? So conversion of decimal number to binary numbers. So for that conversion, we are supposed to hold the data in some space. So that will be stack itself. So that conversion of decimal to base values or a binary value, and conversion of an infix expression into either prefix or a postfix. So for this conversion also, I'm going to discuss this conversion in my coming sessions. Okay, so for that also we are going to use the stack operations or a stack concept. And for quick sort, so we know for sorting we have several methods of sorting: quick sort, shell sort, and we have merge sort, and I have discussed about the insertion sort. When it comes to the quick sort, there also we are going to use a concept of stacks and runtime memory management, and mainly to solve the Tower of Hanai. So these are the applications where is a possibility of using stack concept. And this is also very important question. Just mention the applications of a stacks. Okay. I hope you all understood with the stack concept, and I am going to meet you in the next session with a further concept of this data structure chapter itself. Until that, keep learning, keep on growing. Thank you.